Hello everyone. In this video, we're going to be integrating an interesting rational function. Now, why is this interesting? Because we have a quintic in the numerator, and we're dividing by a quartic, so which should bring some interesting results, right? We have x to the fifth divided by x to the fourth plus 1, and we're going to integrate it with respect to x. And I'll be presenting two methods. Let's start with the first one, because first one is not my favorite, but you get to decide which method you like better. So first, I'm going to go ahead and do the polynomial division. If I divide x to the fourth plus 1 into x to the fifth, x to the fourth goes into x to the fifth x times. If I distribute, I get x to the fifth plus x. Negate and add, you're going to get minus x as a remainder, and x will be the quotient. What is that supposed to mean? Well, it just means that you could do the division this way. You could just basically add like x to it and subtract x from it, and then divide by x to the fourth plus 1, which would give you the following, because this allows you to kind of split and simplify, and then you would get something like this. Of course, you can factor out an x here, x to the fourth plus 1, divided by x to the fourth plus 1. These two cancel out, minus x over x to the fourth plus 1. So the same thing is indicated by this division problem, where you can use polynomial division. Okay, so now here's what I need to integrate. X divided by 1, which is just x, obviously, right? X dx minus x divided by x to the fourth plus 1 dx. Now, integrating x is super easy. It's just going to be x squared over 2, right? And you can add the constant at the very end. But what about x divided by x to the fourth plus 1? You can't divide. Denominator has a bigger degree. But here's what you can do. If you know how to factor x to the fourth plus 1, you can use partial fractions. Isn't that cool? Yes, absolutely. So here's how you can factor x to the fourth plus 1 with a little trick that you should know. We're going to add 2x squared and subtract it, because this makes the first three terms a perfect square. It's just perfect that this becomes x squared plus 1 quantity squared, and this could be considered root 2x quantity squared. Awesome. Now what do we have? Difference of 2 squares. Isn't that awesome? Now you can go ahead and factor it. X squared plus root 2x plus 1. I just switched the sides, but it's a squared minus b squared basically. Just written differently. Hopefully you know that. You should be very familiar with this if you're solving any type of math problem at this level. So that's the way you can factor x to the fourth plus 1, which is kind of surprising, right? It has a lot of factors. I mean, 2 factors, but a lot of terms. So to be able to do the partial fractions, here's what you need to do. You're going to go ahead and split it up into two expressions like this. First of all, it's going to be written like this in the factored form. And then from here, you need to figure out how to do the rest, right? But I'll show you, don't worry about it. Let me go ahead and erase this so I can make some room. And I'm going to move this guy over here a little bit. There we go. Now, here's how we can do the partial fractions on this. Since there are 2 factors and they're not factorable like easily, so we can kind of write this as follows. We're going to have these quadratic terms in the denominator, obviously. So there's going to be 2 fractions with these denominators. That's the whole idea. Basically, kind of like unadding these 2 fractions. Makes sense? Or splitting up a fraction into the sum of 2 fractions. And the numerators are determined by denominators. Because these are non-factorable quadratics, the numerator has to be 1 degree below, which is linear. So we have to have something like ax plus b here and cx plus d here, where a, b, c, d are constants. Make sense? And of course, to keep a long story short, I'm going to give you what those constants are going to be. A will be 0, b will be negative 1 over 2 root 2. If you do the math, or if you use Wolfram Alpha like me, being lazy, you're going to get the following values. Great. Now, what are we going to do with those? Plug it in, but a is 0, so actually they're not even linear, and that's perfectly fine. Constants will do the work because these are opposites. Everything else is going to cancel out when multiplied by b's and d's, so on and so forth. Anyways, you get the idea. You can always check it out. But here's what we're getting at the very end. I'll just ignore the integral of x, which we already know, but this should give you something like this before integration, okay? You're going to get something like this. I think that should be 1 root 2, not 2 root 2. Otherwise, that'll be like a perfect square. And the other one should be a minus sign, because d is negative, right? And if you want, you can pull out the 2 root 2, but you're going to realize soon that that's not necessary. Actually, it's better to keep it inside. Okay, now, how do you integrate something like this, right? The question is, the million-dollar question is, how do you integrate this with respect to x? And let me tell you, you can go ahead and do this. First of all, don't pull out root 2, but pull out root 2. Because when you do that, let me show you one of them so you can do the rest. You're going to get 2x squared plus 2 root 2x plus 2. If you look at this very carefully, it's x squared, 2x squared plus 2 root 2x plus 1, sorry, plus 1. And the reason behind that is this is a perfect square. Wait a minute, I messed up somewhere. It should be 2x squared, yes. Okay, here we go. So this is root 2x plus 1 quantity squared plus 1. So what is that going to become? This is going to become like this. Let me show you. Maybe I should write it as 1 plus. I don't know. Yes. Now, if you call this u, this is u substitution, you get 1 over 1 plus u squared. You know what that means? It means arc tangent. And you can proceed with the formula, or, with this one. I'm going to leave it at that because it's been taking too long, right? Let's go ahead and continue with the second method, which is my favorite, which I like much better. Okay? Here's why. Now, with the second method, we're not going to do any polynomial division, but we're still going to split it up in a meaningful way, like this. I'm going to go ahead and take one of the x's and put this with the dx. And the reason behind that is very simple. If you look at it very carefully, this calls for substitution. You know why? Because this is x squared squared, this is x squared squared plus 1, and this is x dx. Now, if you choose x squared to be u, then du would be 2x dx, and I have x dx. So I can put a 2 here and a 1/2 here, and everything is good. Everything is awesome. Now take a look at this. This becomes 1/2 u squared divided by u squared plus 1 du. How do you integrate this? Very easy. You can do u squared plus 1 minus 1 divided by u squared plus 1, which can then be written as 1 minus 1 over u squared plus 1. Now to integrate this, of course, there's a 1/2. Let's not forget that. We only need to use two things. Of course, don't forget the x squared over 2 at the very end. But if you just integrate this, this should give you a t, and this should give you arc tangent of t. And of course, you can add the constant if you want. But what does that mean? What is u or t? T is, wait a minute. Where does t come from? I'm sorry, I got confused. That's supposed to be a du. So this should be in terms of u then, right? Not t. I don't know where the t comes from. U minus, I need some t maybe, that's why. I wrote t again one more time. Okay, maybe I need like a double espresso something. So what is u? U is x squared. So if you replace u with x squared, this should give you the result. But why did the first method give us something different? By the way, there's an x squared over 2, which you should not forget. And I think we are adding or subtracting the other part. Is it added? I think it's added. Yeah, I think so. And then plus c at the end should work, in my opinion. And you can always double check. Because this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out aplusbi, where I focus on complex numbers. And bye-bye.